Today we will complete solving the ministerial question of lesson 3.3. Set of a question, page number 128, question number 1. Determine when the slope of the tangent to the curve x power 2 plus xy equal y square minus 1 is defined. First, since the slope is equal to the derivative of the curve, we find the derivative of this curve. Differentiate both sides with respect to x power 2. Its derivative is 2x plus the first one, x, times derivative of the second function y, plus the second function y times the derivative of the first function 1, equal to 2y y prime. Then 2x equal to 2y y prime minus 2x y prime plus, here we have 2x plus y. 2x plus y. Then factorize the right side by y prime. 2x plus y equal to y prime. 2y minus x. Then y prime equal to 2x plus y over 2y minus x. To be y prime to be defined, the denominator should be not equal to 0. The value make the denominator 0 is set the denominator equal 0, then find x equal to 2y. Therefore, x should not equal 2y so that the slope to be defined. Choice number B. Question number 2. Determine when the slope of the tangent to the curve y square minus 2y equal xy is defined. The same steps on the previous question. Differentiate both sides. 2y y prime minus 2y prime equal to xy prime plus y. Then 2y y prime minus 2y prime minus xy prime equal to y, yes, factorized by y prime. 2y minus 2 minus x equal y. Then y prime equal to y over 2y minus x minus 2. Then set the denominator 0. 2y minus x minus 2 equals 0. Then x should not be equal to 2y minus 2 or 2y minus 1. Choice C. Question number 3. Determine when the slope of the tangent to the curve x equal y plus sine y is defined. Differentiate both sides with respect to x1 equal to y prime plus y prime cosine y. Then 1 equal to, factorized by y prime, 1 plus cosine y. Then y prime equal to 1 over 1 plus cosine y. Then 1 plus cosine y equals 0, and cosine y should not be equal to 1, to negative 1, sorry. Choice A. Question number 4. Determine when the slope of the tangent to the curve x power 2y plus y power 2x equal 4 is defined. differentiate both sides with respect to x. The first function, x power 2 times derivative of the second plus the second function times derivative of the first 2x plus the first function times derivative of the second one plus the second times derivative of the first 2y prime equals 0. Then x power 2y prime plus 2xy prime equal to negative 2xy minus y squared. Factorized by y prime, x power 2 plus 2xy equal to negative 2xy minus y squared. Then y prime equal to negative 2xy minus y squared over x power 2 plus 2xy. Now set the denominator 0, x power 2 plus 2xy equals 0, factorized by x plus 2y equals 0, x should be not equal to 0, and x should be not equal to negative 2y. Choice B. Set of a question, page number 129. Find the second derivative of the function f of x equal x plus 32x to the negative 1. The first derivative is 1 minus 32x to the negative 2. Then the second function, the second derivative equal to negative 2 times negative 32, 64, x to the negative 3. Choice B. Question number 2, find the second derivative of this function. Rewrite this function as x power 2 over x plus 2x over x minus 1 over x. Reduce x with x power 2, x plus 2 minus x to the negative 1. Now the first derivative equal to 1 plus x to the negative 2. The second derivative equal to negative 2x to the negative 3 equal to negative 2 over x to the power 3. Choice A. Question number 3. Find the second derivative of this function. The first derivative f prime of x equal to 3 cosine x. The second derivative is negative 3 sine x. Choice B. Question number 4. Find the second derivative of sine square x. The first derivative 2 sine x times cosine x. This is the first derivative. Then the second derivative of x equal to 2, the first function sine x times derivative of the second negative sine x plus the second derivative cosine x times the derivative of the first cosine x equal to 2 cosine square x minus sine square x. Since cosine square x is 1 minus sine square x, because sine square x plus cosine square x equal 1, then cosine square x equal 1 minus sine square x. Substitute 1 minus sine square x instead of cosine square x, then 2, 1 minus sine square x minus sine square x. Then the final answer is 2, 1 minus 2 sine square x. Choice B. Question number 5. Find the second derivative of 2x plus 1. The first derivative is 2 and the second derivative is 0. Choice C. Question number 6. Find if f of x equal x power 2 plus e to the negative x, then find the second derivative. The first derivative, f prime of x equal to 2x minus e to the negative x. The second derivative, f double prime of x equal to plus e to the negative x. Choice A. Question number 7. F of x equal x power 3. Find f double prime of x. F prime of x equal 3x power 2 and f double prime of x equal 6x. Choice C. Question number 8. Find the second derivative of cosine 2x. The first derivative is negative 2 sine 2x, and the second derivative, f double prime of x equal to negative 4 cosine 2x. Choice D. Question number 9. Rewrite this function as x power 3 over x power 2 minus 4x power 2 over x power 2 plus 6 over x power 2. Reduce x power 2 with x power 3, then x minus, reduce x power 2 with x power 2 minus 4 plus 6x to the negative 2. This is our function. Find the second derivative. The first derivative equal to 1 minus 12x to the negative 3. The second derivative equal to 0. 3 times 12, 36x to the negative 4 equal to 36 over x power 4. Choice A. Question number 10. Find the second derivative of this function. The first derivative, rewrite this function as 3 minus 2 to the x to the negative 1. Then the first derivative equal to 0. Negative 1 times negative 2, 2x to the negative 1 minus negative 1, negative 2. This is the first derivative. The second derivative, f double prime of x, negative 2 times 2, negative 4x to the negative 3. Rewrite it as negative 4 over x power 3. Choice D. Question number 11. Find the second derivative of f of x equal 1 over tan x. The first derivative, f prime of x equal to the denominator tan x times the derivative of numerator 0 minus the numerator 1 times the derivative of the numerator 1 plus tan square x over denominator square tan square x equal to, simplify, negative 1 minus tan square x over tan square x equal to negative 1 over tan square x minus tan square x over tan square x. Reduce tan square with tan square, then the first derivative is negative 1 over tan square x. The second derivative, f double prime of x equal to the denominator times the derivative of the numerator 0 minus the numerator negative 1 plus 1 times the derivative of the denominator 2 tan x times 1 plus tan square x over denominator square tan power 4x. Reduce tan with tan. The final answer is f double prime of x equal to 2 times 1 plus tan square x over tan cube x. Choice C. Question number 12. If y equal cosine square x, then find the second derivative. The first derivative is y prime equal to 2 cosine x times the derivative of the cosine negative sine x. Simplify this function, negative 2 sine x cosine x. The second derivative, y double prime equal of x equal to negative 2. The first function, sine x, times the derivative of the second, negative sine x, plus cosine x times the derivative of the sine cosine x equal to negative 2 negative sine square x plus cosine square x equal to negative 2 cosine square x minus sine square x equal to negative 2 cosine 2x, since cosine square x minus sine square x is equal to cosine 2x from the rule of trigonometric function. Then the right choice is C. Question number 13. If f of x equal to sine square 2x, then find f double prime. F prime of x equal to 2 times 2 sine 2x times 2 cosine 2x equal to 2 times 2 times 2, 8 sine 2x cosine 2x. F double prime of x equal to 8. The first function, sine x, times derivative of the second, negative 2 sine the first function, sine 2x, times the derivative of the second function, negative 2 sine 2x, plus the second function, the first function, the second function, cosine 2x times the derivative of the first, 2 cosine 2x. Simplify this function, factorize by 2, 2 times 8, 16, sine, negative sine square 2x, plus cosine square 2x equal to 16 cosine square 2x minus sine square 2x equal to 16 cosine 4x. Choice C. Since cosine square 2x minus sine square 2x equal to cosine 4x. Question number 14. If f of x equal x, absolute value x, then find f double prime of 0. Let us find the first derivative. Since absolute value of x equal x when x greater than or equal 0, negative x when x less than 0, then rewrite the function as piecewise function f of x equal to x times x, x power 2 when x greater than or equal 0, negative x power 2 when x less than 0. Then the first derivative equal to 2x when x greater than or equal 0, negative 2x when x less than 0, and the second derivative of x equal to 2 when x greater than 0, negative 2 when x less than 0, and at 0 the derivative undefined, because from left the derivative from left not equal to the derivative from right, when limit when x approaches 0 from left to f double prime of x equal to negative 2 not equal to the limit when x approaches to 0 from right for double prime of x equal to 2. Therefore, the double prime f double prime of 0 is undefined. If y equal x minus 1 times x power 2 plus 1 times x power 2 plus 2, which is true, the third derivative is 0, or the fourth derivative is 0, or the fifth derivative is 0. Since it is polynomial of degree 2 plus 2, 4 plus 1, 5, then the derivative of the degree 6 is 0. Therefore, the right choice is none. And the derivative, the sixth derivative of y with respect to x is 0. Question number 16, find the second derivative of this function. The first derivative equal to 2e to the 2x minus 3 sine 3x. The second derivative of x equal to 4e to the 2x minus 9 cosine 3x. Choice A. Question number 17, find the second derivative of this function. The first derivative equal to 3x power 2. Rewrite this function as x power 2 plus 2x to the negative 2. Then the derivative is negative 4x to the negative 3. And the second derivative of x equal to 6x plus 12x to the power negative 4. Rewrite it as 6x plus 12 over x power 4. Choice B. Question number 18. Find the second derivative of 1 over sine x. The first derivative, f prime of x, equal to the denominator times the derivative of the numerator 0 minus the numerator 1 times the derivative of the denominator cosine x over sine square x. The second derivative, f double prime of x, equal to the denominator sine square x times the derivative of the numerator negative sine x. It is sine x minus the numerator negative cosine x times the derivative of the denominator 2 sine x times cosine x over sine power 4x. Now factorize by sine x from the first term. We have sine square x minus times minus plus 2 cosine square x over sine power 4x. Reduce sign with sign. Then let me complete this question here. Reduce sign with sign and rewrite 2 cosine square x as cosine square x plus cosine square x. Then sine square x plus cosine square x plus cosine square x over sine power 3x. Since sine square x plus cosine square is 1, then the final answer is 1 plus cosine square x over cosine cube over sine cube x. Choice B. Question number 19. If f of x is this graph, then which one of the following graphs is for the second derivative? Let us find the graph of the first derivative first, then we find the graph of the second. I'll find the graph of the first derivative here. As you see, this function has two horizontal tangent lines at 0 and at 2. Therefore, the graph of the first derivative should intersect with x-axis at 0 and 2. And the function from negative infinity to 0 is decreasing. Then the first derivative should be under x-axis from negative infinity to 0. From 0 to 2, the function is increasing, then the graph should be over x-axis. From 2 to positive infinity, the function is decreasing, then should be from 2 to positive infinity should be under x-axis, and the function should be intersect with x-axis at 2. So this is the graph of the first derivative. For the second derivative, as you see, the function has a horizontal tangent line at 1. Then the graph should be intersect with x-axis at 1, either this one or this one. The function is increasing from negative infinity to 1, then the graph should be over x-axis, or the graph here is under x-axis, the graph here is over x-axis from negative infinity to 1, and from 1 to positive infinity, the function is decreasing, the graph is under x-axis, then the right choice is D. See you next lesson.